Hello, everyone. Let me review what we had in the previous lab. So in the previous lab, we wanted to connect to the Hadoop environment or Hadoop ecosystem and do some basic data management stuff like creating folders, upload files, downloading some files, deleting folders, so on and so forth. So we did in two ways. First of all, we connect to a virtual server over VirtualBox. So we either connected to the Untitled dashboard or command prompts. And then through that virtual server, we connected to Hadoop Ecosystem. So we have seen through Untitled dashboard, we might have some challenges, especially since it's a third-party software which running a very heavy file system. It might take a lot of time, and some of you got some errors like 502. It just means your system is still running and hasn't loaded completely. We did it through, then we had those experiments through the Untitled dashboard. In the second trial, we used either a Mac OS command prompt, or we installed Putty for the Windows users, and the IP address was Mario_DEV @127.0.0.1, and the port was 222. The username and password both were MarioDev. So we connected to the command prompt, and we did something similar, actually, like creating folders, unzipping files, like deleting those files, so on and so forth. Also, for some of you had issues, especially uploading the files. So I introduced WinSCP in one separate video. So it makes your life much more easier. First, you need, after installing, just press Control and then N. So as you see, you might see one empty login page. So you put your host name, again, is same. So, and port 2222, user and password, both are Maria_DEV. Oh. So, and also you can save your information. So next time, when you, as you see, I save it the HTTP name. Then next time I don't have to type everything and just press login. Please watch the video, I put a lot more details there. So let me just log in here. By the way, at first you should load Hadoop ecosystem. So the Hadoop should be running. As you see, this command prompt just said Hortonworks Sandbox HTTP 2.6.5 is running. After that, you can run WinSCP. So on the right hand, as you see, it's my Hadoop ecosystem on the Maria_DEV folder, and left side is my local system. Let me just drag and drop one file like bbb.pvtx or a PowerPoint file. You can just drag and drop. Okay. Okay, you can just select, drag, drop, or you can just right click on the file. As you see, I right clicked on the file, then there's an upload section and you can just upload it. Press OK. Yes. So as you see, bb.pptx is in my Hadoop ecosystem. Again, anyways, is fine. So it was what we covered in the last class. Again, sorry for the technology problem, because for the this today lab, which I recorded later, I needed to tell you how to install some packages. So we need a strong internet, but unfortunately we had issue in the School of Management or clerk in general. So I had to record the video later and post it for you. So what is today experiences? So in today experience, we want to see how we can do everything from scratch instead of using Hadoop ecosystem. So for doing parallel processing and or other jobs in that is very common in Hadoop, you don't have to have Hadoop, but having Hadoop makes your life much more easier because some other developers already developed technology, so you don't have to code everything from scratch. But for today's lab, we do some parts from scratch, which is doing map reduce. So instead of letting Hadoop does map reduce for us, we do it by ourselves. So as you see, here I put a table of our data. So we have 4 columns: user ID, movie ID, rating, and timestamps. In this experiment, we want to have a map reduce function, which is again is the methodology behind Hadoop ecosystem. We want to see how many ratings was done by one user. In the first step, which is shuffle and sort, basically we pick each user ID and put the movies that they rated. So as you see, we sorted based on the user ID. So user ID 202, rated movie 302 and 51. So it's the reason here you see that. Or user 196, reviewed 242 and 377 and 474. So in front of a user ID 196, you see these 3 movies, and same for ID 166, he or she just reviewed 1 movie. So these are, we shuffle and then basically sort our data. In the last step, we reduce, so we just count how many movies they reviewed. So for ID 202, we have 2, ID 196, we have 3, and just 1 movie for ID 166. Okay, sorry, even back home, my internet is disconnected. So let me just review. So in the first problem, we want to see how many movies was reviewed by each user ID. So first we shuffle and sort based on the usernames and then count how many movies they reviewed. In the second problem, we want to find distribution of ratings. So how many people had rating of 1? So here just 2 people, rating of 3, 2, 4, 1, 2, just 1. So first we shuffle and sort based on the ratings. So rating of 1, there is 1, 1. Rating of 2, just 1. Rating of 3, 1, 1. And rating of 4, just 1. Then we reduce. So this time, reducing function is summation. So we sum up how many ones for each movie rating. So we end up knowing that 2 people rated 1, 1 people 2, 2 people 3, and 1 people 4. So you might say it might be a little strange why I assign for each ratings, I assign number of 1. Actually, there's multiple ways. The way that I did is one of the easiest ones, but if you find a better way, that's totally fine. Even for your assignments, you don't have to do exactly what I said. You can just be creative and use the algorithm that looks better for you. So for the way that I try to solve this solution, this problem, by assigning 1 to each ratings, then summing them up. Because at the end, I want to count how many 3s, how many 1, how many 2, and 4 I do have. And summing those 1s gives me this goal. This is, I recorded it later. I cannot see your questions. So if you have questions, you can reach me later. You can pause the video anytime you want. In case of having any problem, just go back, see watch them, ask me later. Hopefully, we could resolve all of your issues. Also, you can reach me through GroupMe. Okay, so for being able to run Python through VirtualBox and using Hadoop Ecosystem, you need to install some packages and basically update them. Let me just go over there. Okay, so I put all the commands you need to for installing required packages for Python. Let me go over one by one. So, okay, first, for Windows users, we need to get to command prompt within our VirtualBox. So I go to my PuTTY. Select my login. Again, the password is still Mario_DEV. And now I'm reading Hadoop ecosystem inside my VirtualBox. So first, you need to get to root privilege. Basically, the user privilege is not enough for installing packages. You need to go one level upper. So you get to the root user of Hadoop ecosystem. I put the comment here. You can just copy and paste, but it's just su root. First, the initial password is Hadoop. So here you should type Hadoop, and then you get to the ecosystem. But since I already log in, so I don't have to put yet Hadoop. I'm just putting my new password. Just look at this PowerPoint. So as you see, after su root, I put Hadoop as a password. Now it's asking me I should change my password. So for new password, I use Hamid 2020. You can pick any password that you like. So again, after putting Hadoop as your initial password, you can change it. So Hamid 2020. Now, as you see, instead of Mario_dev as my user, now I'm a root user, so I can install everything within Hadoop ecosystem. First, you need to install Python Pip. What I can recommend, just right-click here, copy, go inside your command prime, right-click. Now it's installing. It might take a few minutes. It depends also your system potentials and what kind of, how many RAMs and CPU dedicated. So for me, it's already installed because I did it, but for you, don't get such a command. So next one, install. Basically, after installing your pip, now we are upgrading them. Again, select, copy, within command prompt, right click. Okay, then we install mrjob package. It's basically, it stands for MapReduce job. So it lets you to do paraprocessing within Hadoop ecosystem. Again, I select, Control C or right click, copy, within command prompt, right click and paste. It gives me some warning, but that's okay. So then I install Nano. Nano is just a text editor, so you can later change your codes. here. Right click. So for you might use different commands because I already installed. So, but when you install, you might get some different results. Next one, I will upload u.data because we are going to run some Python-based MapReduce jobs through the u.data, which is the table of movie ID, user ID, and ratings. And also, I already made a Python code. So just you can download this file. Also, I put it in Moodle. So instead of downloading, you can just go to Moodle, put in your desktop, then use WinSCP, and you can later put these files within your Hadoop ecosystem. But again, it depends. Wget function works as well, which I already taught in the previous class. So do this, and this is actually your next assignment. And if you go here, so for your assignment 3, these 3 installations. So, and after that, by these commands, I can see you'll be able to install it. So pip // version gives me the version of your pip. Nano // version gives your nano editor or text editor version, and same for Python. Okay, run these commands. Let me run my Python command. Again, copy, paste here. So let me just do Python -version. So as you see, sometimes when you copy and paste, the format would be changed. So if you get some errors, like me, just type it. Again, because it could be font issue, especially if so I see from some people who use Chinese as their default system, when they copy and paste, it seems they copy and paste correctly, but even maybe a space character in Chinese and like English could be different or anything else. Again, if your code didn't run like what I did, so first I copy and paste Python // version, I saw that it's not working, so I just copy and paste by myself. I'm sorry, I typed by myself Python -- version. So for assignment, if I want to do assignment, I take a picture from this, I put in my a Word document or PDF document and submit the assignment. Or for I do same for pip. So pip // version. This is the 20.2.2. So I can, if you submit a picture of this through a Word or document file, I can understand you'll be able to install. That's same for nano -- version. Okay, so this assignment give you actually the solution. I think the error was the one space here, so let me just reduce the space. But again, anytime you see any issue, please just type by yourself. Again, for today's assignment, you actually need to know how to install pip, mrjob, nano, and also be able to download these 2 files and put it on your Hadoop ecosystem. Again, you can do it through WinSCP, go to Moodle, or you can download these 2 files directly. For downloading directly, I taught you in the previous class, you use wget function. So let me do that again. So I copy this one, come here, I put wget space, I paste the file name. As you see, now I download it. But for some users, especially I think GitHub is a free platform, sometimes you might get some errors. So in those cases, please do another way. I mean, typing by yourself, or maybe you can use WinSCP and so on and so forth. Since next week, Monday is Labor Day. So let me cover the next lab too. So in the one video, you see two labs. So first, we want to find how many ratings was made by a user. So in the first step, we need, when we do mapping part, or basically shuffle and sort part, as you see, I have self here, which just means input object. So if you did some functions before, probably self makes sense for you. And there is another one, which is line. So it's the one line of ratings. As you see, I'm saying that I split the line, which is your input, with /t, it stands for tab. So what does it mean? Let's say, between 196 and 242, there's a tab. So it's the reason you see in two columns. Between 242, there's a tab. So you get to 3, and same for the timestamps. So the reason I'm saying whenever you see a tab, it just means you should consider a separate number. So what it does, it takes each line, split by tab, so it gets 4 data. First, user ID, movie ID, rating, and timestamps. Same here. User ID, movie ID, rating, and timestamps. But as you see, for finding how many ratings was made by one guy, we just need basically the user ID and the movie IDs. Or basically the user ID and the movie ID. And again, there's another ways too. It's not the only way. So I don't see the rating by itself, and I also don't need timestamps. Same here. So I'm just okay, actually it's for the second one. Okay, it's the solution of this. So here I just need rating, and for each rating I put 1. Same here. I just, instead of the whole of the line, I just picked rating, I assign 1. At the end, I sum up I consider this one as key, and values as 1. Again, I have a reducer function, which I'm saying that whatever you get, so what it gets is here just get a rating and 1, sum them up based on similar key. Let me go here. Again, sorry, this is the second problem. So as you see, for each line, just pick ratings and assign 1 next to it. Then each rating is a key, rating of 1, 2, 3, 4. And some of the ones, the values that is in front of it. So key of 1, rating of 1, 1 plus 1 2. Again, for 2 is just 1, for 3 is 2, and for 1. So it's the definition of this function. So the key is the rating, and is sum of all the ones to find how many people rated 3, 2, 1, and others. Here there's a whole function. So the first part is just importing packages. Then I put basically I define what is my mapper, and what one is my reducer. So here I define the steps. Then I define the mapper function, which is just picking ratings and assigning 1 in front of it. Then the reducer one, based on the similar key, again, the movie ID is sum of all those ones. And this last part, just, I assume you already had Python, but just as a review, when you put name equal main, it just means whenever you see this file, which is the main file, run it completely. So it just means the whole of this line should be run if you consider this one as a main file. So it means you don't import it from somewhere. This is the main file that you're running your function. You might have another file that you import functions from it, but when you put name, if name equal main, just means if it's your actual file, run whole of it. So there's two ways of running your file. First, just using your VirtualBox system. So let me just go here. Two ways of running. First, using this virtual PC or Hadoop ecosystem. Having said that, with Python rating mr.py, it just means use Python, run this Python code, and this is your input file. You can copy and paste. Again, I put also a text file because, again, because of formatting issues, you might get some errors. But let me just come here, right click. So as you see, just said how many people rated 5, how many 1, how many rated movies 2, how many movies of rating 3 we have, and how many movies of rating 4 we have. Let's just copy and paste this one. So here, as you see, just it's kind of similar. It use Python, use this file, but it goes through Hadoop ecosystem, which has these two files, and this is our input file. As you see, it gives me some formatting issue. Now, instead of copying and paste from PowerPoint, because I want to avoid this issue, I go to the text document that I loaded on Moodle and basically copy and paste files from that text document, which is very plain. So hopefully we don't have any formatting issue. Okay, so as you see, when I wanted to copy paste from PowerPoint, I get some formatting error. So from the files that I put here, I mean, open the text file, codes.txt, I put it in Moodle, just select all the code, come here and paste it here. So now as you see it's running, it might take a lot of computations. Just wait a little bit. So in the previous experiment, you see that when we run through Python, it just happens so much faster. The reason Python is efficient for small files like UDAT data that we have. However, Python, or I mean, generally Hadoop ecosystem is designed for the very, very large data set. So it's not very efficient to use Hadoop for a small data set like what you saw. But anyway, we just want to learn. So therefore, although in this specific problem, using Hadoop is not efficient, but it's good for learning. So, but if we had a very, very large data set, terabytes of data, Python couldn't handle, and Hadoop is much more efficient based on both in time and computations. Okay, let's wait a little more. So Again, don't blame Hadoop for being very slow. Hadoop is designed for a very large data set. So let's say you want to have like 2 pounds of a cargo. So if your cargo is just 2 pounds, is most efficient is just using a sedan car. But if you use a large truck for 2 pounds, it's not very efficient. So same here, we used a very powerful ecosystem of Hadoop for just handling a very small data set. But anyway, this is for learning purposes. Okay, so let's look at remaining of our rating problems through the lab 3. I'm looking to this problem. Now we want to see how many times a movie is rated. So it might look very easy for you because in the previous one, you can do based on user ID and ratings, or more specifically, previous one, I count how much a rating is happened. If we want to see how many times a movie is rated, now when we want to do in the mapping or basically shuffle or sorting part, for each line of data, as you see here, we just take movie ID and assign number of ones. So later, if we count ones, we can find how many times a movie is rated. So as you see, we can just simply edit the previous one. Here I put the code. So Nano, as I said, is a text editor. Rating mr.py. This is the previous Python code that we found distribution of ratings. Now I can come up this line because now we want to count how many times a movie is rated. So instead of counting rating, we can just put movie ID. Then look down here. So after doing my change, I can press Ctrl X to exit. And just ask me, do you want save or not? So if press Y, you save and later you can run it. Or you can just simply press no. So it depends on you. Again, let me do it again. So Nano, I go down and change rating to movie ID. Ctrl X, look down. Here said for exit, press Ctrl X. This time I say yes. I ask me, do you want to save it? So I can just change the name here. So I change it to maybe movie MRs or movie rate counts. Press yes, and I can just save it. On top of that, I put the code, so we can just do wget, or that's sorry, wget, copy this link, paste it here. I can download from web, so either way is fine. So now let's see how it works. So as I said, there's 2 ways of doing it. One through Python directly, and the one using Hadoop ecosystem. Again, it might be some font issue, so you can just copy and paste from text document. So let me show it to you. So here I select the text document, copy here. So it's running. So anyway, we can edit it here. So Ctrl C. So I go to the next line, Ctrl V. So this time, almost everything is same, but so the UDA data is same, Python ecosystem is the same. I just need to change my file. Instead of rating MR, I can use this file, which is movie MRPY. So movie mr.py. So I select this line, Control C, and just let this finishes. And because I just copy and paste previous one, then I copy and paste new one and see the result. Okay, so I just copied the second line that I modify in the text document and just paste it here. Now we are waiting to see how long it might take. So as I said, this is a code that uses Python environment through Hadoop ecosystem. It might take for a while, so we can just, might take about 2 or 3 minutes. So you can see how many times a movie is rated. Again, in the first program, we count how many times a type of rating, either 1, 2, 3, 4, 5 is counted. Now we're counting movies. So here you see so much of calculation inside Hadoop. For example, it's checking different connections and like movies. So look here. So on the left side, we see movie IDs. On the right side, how many times they are rated. So it might bring some questions for you. First of all, the order is based on movie ID. So you see 981, 982, then 99. It's just kind of alphabetically ordered. So 99 shouldn't be here. It should be way above, but it's not numerically ordered. Also, we don't see the highest rated movie, or highest mentioned movie, and the lowest one. What can we do? First of all, we can order based on how many times those movies are reviewed. And also we can change the order to the numeric. So because the default, in default, Hadoop considers everything as a character. So we need basically change the right side, which is how many times a movie is rated, to a numeric format, then order them based on this fact. So order based on the numerical thing. So we need to do two changes. First of all, we need to add a step of sorting. So as you see in Python code, first we define mapper1 and reducer section. So we said, okay, this function is mapper function, this one is a reducer. So now, since we want to reorder them, we need to add another step for reducing, so which is reducer underline sorted, and these names are all arbitrary. Besides, there is a way that you can change default of Hadoop from character to numeric with the z field function. As you see, after a value, we can add the method of z fill, and it's just saying, okay, use 5 zeros for padding, 0 padding. For example, 4 is equal to 0004, 80 is 00080. So if you do this padding, now Python assumes these are numbers, not character. Again, this is not the only way, so there might be different ways of doing that. So as you see in the reducing rating, now I'm saying that when you sum up those ones, because for each time a movie is rated, it is considered 1, then if you sum them up with some function, yeah, it gives you the total number of a movie is rated. We put all of them in the str function. We just force Python, yes, this is a str, or character. Although it by default is character, but it's better to do that than adding method of zfill and then key. So as you see, this function has two values. The first value is how many times a movie rated, and the second one basically is the movie ID. However, look previous outcome. Let me show it to you here. So the first one basically here now would be sum. The second one is value, but we just need to switch them. So in the second reducer one, I'm just saying that, okay, we know that the first one, the first outcome is the summation or counts. The second one is movie ID. Now do a for loop. So for all movies inside the movie, switch count with the movie. So it's just replacing these two columns. Again, the output of the first one is just movie ID and summation of them. Here, I just switched them. I know you might find a much better, efficient way, but let's look at the function right now. So first, we import the packages we want to use. Then we define the mapper and reducer steps. So as you see, we have two steps. So first, mapper and two others are reducing and sorting. So then we define the rest is same, defining the mapper section, reducer, and just sorting. And as you see, name equal main. You might see some little differences between this one and Python 3 that is default in School of Management. So we are using Horton Sandbox. The default Python is Python 2. So it may be a little different from Python 3. And the goal of this course is not learning Python for Hadoop. We're just doing some experiments, seeing what happens if you do everything from scratch. Again, you can do it in two different ways. One way is just do nano edit. So as you see, you can do nano and the previous file and edit it. Also, I put the solution in this file. You can just do wget and this address, download the files and run it. Okay, now if you want to run it, so instead of movie MR, the file is movie rated sorted.py. So again, I don't recommend to copy and paste from PowerPoint because you might have some formatting problem. So I just copy the previous code down here. I just need to change because movie MR is the previous one. I copy this name. Okay. Now I can copy and paste this code into my command prompt through Putty and ask Hadoop Ecosystem to just do these sortings for me. Here, paste. Okay, that's great. As you see, now on the left side, we have movie IDs, and on the right side, how many times they are rated, and everything's sorted right now. So sorting based on how many times the movie rated. So let's see, the lowest movie is rating is just one. The highest numbers that the movie rated with different people is 583. Again, especially if you have some background programming, I recommend try to just code in different ways. You don't have to follow my exact code. This is a good practice. Now, let's look at the assignment of this lecture. I mean, we have two labs, and this is the associated assignment. Okay, this assignment is kind of challenging, but I just recommend you spend a good amount of time. We have 2 weeks, and no worries. In one of your next labs, I give you the solution. So let's look at the assignment. So we have seen that we have different users that rated movies. We want to see what are the nicest people. What I mean nicest people, they rated usually high to all movies. Let's say you have some nice professor, they give A to everyone. They might give you hard assignments, but at the end, maybe everybody gets A. But some professors, maybe they're not that much nice. So similar concept here. We want to see if we have which user IDs are the nicest and give the highest average rating. Look at this example I posted here. User 22 has 3 ratings of 552. If you divide it by 3, it's 4. User 0 has average rating of 3, and user 196 has average rating of 1.5. So user 22 has the highest rating average. We want to find top highest, top nicest people, top 5 people with the highest ratings in this data set. I provided some hints here. So first of all, you can use your calculator. I know it's a little challenging, so you can use a file if it's very tough for you to make it in one file. But you can have multiple map reduce. So as you say, you saw we had 2 reducer, but you can add more. For making a rating be considered as an integer, because you want to do calculations, you can use int function. Let's say rating of 3. I said the rating is usually string. If you put int, you convert it to a number. Again, you don't have to follow my hints. You can just do whatever you want. At the end, I want to be able to put your creativity and try hard. Again, the goal is not doing MapReduce by Python in this course. I want you see that's challenging. Maybe you can use some dashboard technology like Ambari. But I want you to spend a good amount of time, no worries. Again, since it's not the main part of your class, I just want to see if you put some good efforts and try to solve it. I think if you don't distracted, if you spend good amount of time, you will be able to solve this problem. And in your next class, I give you some lectures and I explain these Python files that we had here. So in case you have questions, you can ask me in the class. But for now, just consider this assignment as your next. Hopefully, I think if you spend good amount of time, you can help each other. And what I mean helping, so you can help each other for this assignment. I don't consider it as a cheating. So you can use Telegram, help each other to solve this problem. Many of your assignments are group assignments like this, so you can help each other, but you submit individually. And But for some assignment, you shouldn't help each other. So those are individual problems. So this one is not. And I want to encourage you to help each other through Telegram. Hopefully you can solve. Definitely try to refurbish my previous codes. And even you can Google it and put with your creativity, hopefully you can solve this assignment. That's for today. Again, sorry for the technological issue that we had in the previous class. Because I wanted you guys to install some Python packages and like upgrade your Pip, and you couldn't do without internet. It's the reason I canceled that class and made this offline video. Anyway, that's for now. I hope you enjoyed the remaining of your holiday, and see you in the next class.